16 over 15 feet per second. Okay, we did all of these today in class. Air is being pumped into a spherical balloon at a rate of that. So dV dt is 24, positive 24. Okay, so first off, we need dr dt when the volume is that. So the volume, 4/3 pi r cubed. 2403 pi is 4/3 pi r cubed, divide by pi, multiply both sides by 3/4. You get the radius is 2. So that's the volume formula. Take the derivative. All right, take the derivative. You have dr dt. Again, the 3 comes down, power rule, cancels off with the other 3. Then we know the radius is 12. Plug that in right there. And let's do some solving. All right, again, pi's in the denominator. Don't forget that. Number 18, oil is leaking from a cylinder at a rate of that. So the dV dt is negative. I want to find, so when the height is 45, the radius is constantly 12. I want to find dH dt when the height is 27, I'm sorry. R is constant, so its derivative is 0. So we don't have to use the product rule. Because R is constant, I can just let R be 12. Some books will show the product rule there. All right, negative 22 is equal to pi times 144 dH dt. That's pretty easy there. All right. Optimization question. A farmer has 3,200 feet of fencing. That's the perimeter. I'm going to draw it like this. That's a river, so I just have 2 sides of x, 1 side of y. Area is x times y. 2x plus y is 3,200. I'm going to solve for y in terms of x. So area is x times y. I'm just going to rewrite y in terms of x. That's the area. Then right here, I take the derivative and set it equal to 0. Because if I want to maximize largest area, the maximum is when the derivative is equal to 0. X is 800, and then just plug it in there. You get y is 1,600. So 1,600 by 800 feet are the dimensions. And lastly, folks, I told you not to worry about 21 or 21. 21's not going to be on there. So lastly, with 20, a box with a square base and open top right there. It's x by y, and the top's open. It's got a volume of 32,000, I'm sorry. So volume is length times width times height, x squared times y. That's 32,000 is x squared times y. Figure out what y is. It's 32,000 over x squared. All right. I want to minimize, right? Minimize the amount of material used. That's surface area. I have a bottom that's a base, x by x. Then I have 4 sides, because the bottom's a base. I have 4 sides that are x by y. Instead of writing y, I'm going to write 32,000 over x squared. I get some cancellations. X will cancel. Remember, folks, that's the same thing as 128,000 times x to the negative first, which is important when I take the square root. Not square root, the derivative. All right, take the derivative. Take the derivative right here. Set it equal to 0. I'm going to move the 128,000 over x squared to the left. Cross multiply, divide by 2. X is 40 when you take the cubed root. So use that.